Okay. In essence, we want to cover today a performance enhancement for your sequence solution. To see what we can do, there's a famous saying: you can never have too much money, too much backups, or too much CPU. And the equivalent over here, the sequence equivalent, is performance. You might need this after setting up sequence just now and finishing up your deployment, and then you come to the conclusion um, that you perhaps could do better. You could optimize. You could make it better, or you might have had sequence deployed by you for quite a while now, and only recently noticed a slow degradation. As the database grows, as you get more and more usage occasionally, you need to tweak the system. You need to optimize it. You need to have another look at how you're indexing, how you're storing data. We'll get to all that in a bit. The first thing we should cover before we dive down into the details of how to optimize and what to optimize is just a quick reminder of what makes sequence tick. How are the different parts of the system integrated with each other? So you have at the middle, everybody is talking to it. Most pressure is exerted on it, and normally in any sequence topology, it's the most powerful server. It's the database server. It could be one, it could be a cluster, but everybody's talking to the database server. Around it, you have the administration, the runtime running under SharePoint, the background runtime service running under Windows, and the Active Directory service with one leg querying the LDAP server and the other updating the sequence SQL database. Of course, the topology can be one server for all, or a different division. In this case, for simplicity's sake, I'm showing it as different servers, but the idea over here is quite obvious. So you can see intuitively that since SQL is at the middle of everything and everybody needs to talk to SQL and read from SQL and update SQL, then the obvious place to start is to check if you want to optimize sequence and maximize the outcome of what you're doing is with SQL. Most of the optimization we're going to be talking about today is, of course, SQL oriented. We're going to be covering in the first part how to analyze the usage, how to check and improve your indexes, and how to look at the SQL profiler to get an idea of what you need to do. The result of that can either be hardware optimization. Sorry, just a second. The result of that can be either hardware optimization or software, which would be simpler and less heavy on the economic aspect. Okay, so let's start the first part, the SQL element. If we go on over to our server, in this case, of course, this is a demo environment. It's a single server solution. We're going to look. The first thing we want to have a look at is how much pressure is your sequence solution under. How many people are using it? There are many different indications you can get for it. For simplicity's sake, for this webinar, I chose to count activities. Activities created incorporate both the server side and the human interaction in a general way. So the more activities you have, generally speaking, the more your sequence solution is under pressure. So simple select that just concatenates month and year and gives the number of activities created during that month. You can look at it in raw data. It's a little bit difficult to see. So we can, but again, we're not going to be dealing with design. Just quickly copy and paste it into Excel. Even before we expand it and make it all pretty with all the dates and everything else, we can see a very clear trend. In our test environment, we had an average running around 2,000 and something activities created per month. And then recently a gradual but consistent and quick spike upwards to 9,000 activities. This isn't consistent proof that you need more, better hardware, but this is the first indication. Okay, I know if I had 2-second response times a few months ago and now it's up to 6 seconds response times, the first indication is over here. I'm getting more usage. So we have to see what we can do to see if we can make room with a data optimization solution, or if we need something else more complicated with hardware. We go back to our server again. So we checked right now the basic usage stats, and it gives us a first indication. What's going on? What was there before, and what is there right now? It's not always applicable, especially if the solution is relatively new and the statistics aren't yet conclusive. Another important thing that you can check, this again, now we're on the system side, is the indexing in your database. Generally speaking, the more your indexes are fragmented and the bigger the specific table that the index covers, the multiplication of those, it gives you a clear indication of how slow your system will be. And the bigger the database and the bigger the tables and the more fragmentation you have, the more in a almost unnecessary fashion your solution will needlessly chug along. Each table will have typically between 3 and 10 different indexes, one clustered, which means it's based on the primary key of the table, and that's the one that will always be the most efficient and the fast and the most important one, and several non-clustered indexes that are based on other fields, but that are used when those other fields are the category which certain select in the different stored procedures base themselves on. So if I have TBL action items, which is the messages and tasks that go out to users, of course it has its own key based on the FLD ID. I'll also need to have a good index on the workflow instance ID and the activity instance ID in there, because a great many of the stored procedures will be grabbing action items based on those two. We'll be querying based on those two. So if we look at our table over here, I'm not going to fix it because we have to see the effects of this later on. This is a highly fragmented database. You can see some of the biggest tables, TBL action items, which has I think several 100,000 records, is fragmented to the very limit. These UAC tables, each of which have I think on average 30 or 40,000 records, are also heavily fragmented, and the overall result of this is a needlessly slow database. Because if we go about and think how to re-index and do that as on a regular basis, then the results would be we would expect the results to be significantly faster. Now, depending on the solution, there is no one right re-index solution, because it really depends on what you're trying to achieve. Depending on the function of the table, whether it's heavier towards reading functions or heavier towards writing functions, the indexes have to be entirely different. If you have a UAC table that a task or a form is based on, the most important thing you want is when the user hits submit, you want the user to get to fly right through, and for the writing to the table to be quick. You don't care later on the background service might take an extra 1/10 of a second or 20th of a second to get the data, because we want the user experience. So there is no single correct re-indexing solution, but in general, what you want to do is a simple command, dbcc re-index, give it the table name and the filling. The higher the number, the more read-oriented it is, generally speaking, and it will address the indexing issue, and it will improve the performance that your users experience. There's an old Russian saying about what you can look at, three things you can look at indefinitely. It's a fire burning in a bonfire and water flowing in a river and other people working. And the SQL profiler is in essence a good view of other people working. What we see over here is almost each and every query or stored procedure or any work that SQL is doing. It displays it over here in a variety of data, primarily the ones that we're interested in are the text data, the actual query that's being run with the parameters that are being sent to it, the duration, how long it's taking for SQL to finish and return return an answer, and the more mundane, the start and end time. You want to get an idea of what time your server is most and least under pressure and responding differently. You would expect the Monday morning spike when everybody logs in at the same time. You would expect the durations to go up within a reasonable amount to a reasonable level, and you expect them to be extremely low when after everybody's left and the background runtime service has had the opportunity to clean up the round of work left at the end of the workday. Now, looking at this right now, we're seeing what's happening at this moment on the server. But that doesn't necessarily give us a true indication of what's going on. And we can't sit and stare at the screen and try and fish out the activities whose duration is taking long. Because it can be, as I said, you can have spikes at a certain amount of time, and by the time we have a look at it, everything is working nice and dandy. The way to go about this is to set the profiler to run for a period of time, half a day, whatever, and to collect the data. You should note that there's an overhead. The very running of the profiler slows everything down, so you shouldn't run it indefinitely because it will cost. It will have an overhead, as I said. So instead of looking at this ongoing, slowly rambling profiler, which doesn't really give statistical information, we can close this up and have a look at a pre-generated trace file. Now, this pre-generated trace file is in the same idea as the others. It's just static. It's whatever we had. It's 5,000 lines collected over a few hours, and it has everything that we had over there in the ongoing trace. The difference is now we can collect over a significant amount of time. We can filter the results to see what we want to see. There are several ways to go about it. I'll be detailing two of them briefly. First, based on duration, and then I'll have a quick explanation of the different naming conventions so that you can know which ones are most important to look at. I want anything that took more than 4 seconds to complete, because my idea is, for grossly speaking, anything that takes more than 4 seconds is at least initially suspect. In that it can be delaying my users, it can be creating a negative user experience for everybody. The SQL segment is a little bit rambling and ongoing, so I'll stop now for questions. If anybody has questions, you can send them either through the chat or through the question module, or I will be unmuting everybody and you can ask questions through the microphone. Okay, we'll move on now then to the analysis of the results from the profiler, and continue with that. Just one moment, please. It's a good question regarding database server specifications. And really, there is no one single answer. Generally speaking, as I said, the database server has to be the most powerful server of them all because everybody is querying it. But it really is a function of how many workflows you're going to run, how many users will be running the system, concurrent usage, number of expected workflows that you're generating over a period of time, the depth of the archiving that you want to keep. Normally the mode of operation would be it's a consultation that we would have with our technical team. These questions and a few others you would answer those, and our product team would supply you with an estimate of what sort of specification you need, depending on the specific needs. So coming back to the recorded data, we have out of those 5,000 activities, we have 13 that took more than 4 seconds to complete, and the worst of them all, at 12.5 seconds at the time, was this one. It's a stored procedure. It's not a system stored procedure, but possibly customized stored procedure. But in any case, the idea being it took 12 seconds to complete, and we're wondering why. Generally, you should know that you shouldn't run stored procedures blindly, because if they have right functionality, then it could be disruptive. In this case, I know what this stored procedure is doing. It's a read-based stored procedure, and if I run it by me, I can already tell that it's slow. It's running for 6 to 7 seconds. It's taking a while to complete. So that it's a good candidate to get an idea of what's going on. Now it took 18 seconds to complete, but it doesn't give me any idea. The data itself doesn't give me any idea beyond the fact that it has a reasonable 7,000 and something lines in one of its subqueries. The way to have a look at this visually, to get an idea of which part of the query is heavy, which part of the query we might be able to optimize, is by including the actual execution plan. Again, this, like the profiler, has an overhead of its own, but it's worth it on these diagnostic testings to get an idea of where we can improve ourselves. And when we have a look at the execution plan, we can see a few indications that I'll be going over shortly. The execution plan, in essence, in each row divides up the work that was done over these 21 seconds. We want to, of course, concentrate on the heaviest bits and try and see within those heavy bits what took it so long. What were the heavy elements that gave it a hard time? So we have over here the first line, which took 58% of the time. And this is the one that we want to elaborate on. If we fix this one, then we fix a great deal of the problem. Now, what does it tell us over here? We're not going to go into the depths of this. Execution plan analysis is an art of itself, but 2 points that you can easily see that'll give you an idea. The first point is in the width of the arrow itself. The wider the arrow, the fatter the arrow, the more lines are getting carried across each time. if you can see it, the number of lines and the number of data that are getting carried across. In this case, it's not a large amount. Relatively speaking, the fatter the arrow, the more data that's coming across. And many times inside stored procedures, without paying attention, you'll have select all from a table, when in essence you really need a lot less than that. And if you limit it, you can see it. Now by looking at this, you can see exactly where it's coming from. It's coming from TBL instance workflows, and you can see exactly the parameters, the fields that are coming out, FLD ID and FLD last updated, and you can see you can optimize your query in that way. The second thing that you can see, very importantly, is that 66% out of the general 58% is because we were reading out of a specific UAC table, UAC 517.000.185, and it doesn't have an index on a specific field on the FLD IWF ID field. If we go into the table and we add that index, just a moment. The database in question over here is an older version of Sequence, by the way. That because it's easier to find performance problems there. The newer versions couldn't find anything convincing. So we have a query that's based on FLD IWF ID, the workflow instance ID, and there is no index for it. Before we go into this, just 1/2 of a minute to quickly cover an important bit. Indexing is a fine art. You can have too many indexes, and you can very easily overdo it, and they can cancel each other out. So when you add indexes, you should consult a DBA, or you should work in very small steps to make sure that adding an index is not counterproductive. So we will name our index for whatever we want to call it. It has to be non-clustered because the field isn't the primary key, and it's definitely not unique. And we place it on FLD IWF ID. Indexes take time to build, so we're not going to wait for it for SQL to work in the background and slowly get itself to build. We'll give it just a few seconds. In the meantime, I'll cover a few of the other more theoretical aspects of SQL database that we haven't covered yet. When you have databases, especially large databases, it's a good idea to separate the different elements of the database to different physical disks. Especially when you have high-end solutions, they're RAID. Your DBA can tell you how to place the data file and the log files and the indexes on separate physical drives. This has a positive effect on performance because they're each physically reading with different pointers and will work. Whatever we're doing here, be it the re-indexing that we spoke of before and creating indexes, generally speaking, it's always best to do it preventive maintenance. When we come into it as an emergency, it's always going to be harder to implement and of course costlier. So the preventive aspect of this is very important. So we let it work for a few minutes. We let the index be created, and if we execute it again, we should see some difference in the results. We'll have a look at the execution plan for a second time, and we'll see what we see over there in the results. So, sadly, adding the index only removed 2 seconds out of the 21. And if we look at the execution plan, however, we can see that there's a whole subdivision What took before 58% of the time is now only 33% of the time. And what took, I think it was 60 something percent of that out of that is now down to 19% out of that time. So our index, we can see, while overall only removed 10% of the time, was a step in the right direction. You have to look through the rest of it and dive into it specifically. But as I said before, depending on how fat the row is, relatively, so over here you see this is 23,000, even though it looks to be almost the same size, and you want to find those activities that it warns you, like it did over here, when you have a search based on the field without an index. So let's take a second to go back to our slides and to quickly review what we've covered. When you're looking at the database, you want to first get an idea of your usage. How much pressure is being exerted on the database server, as we saw the query over there. By the way, I'm not sure if I said this before. All the content, the scripts and everything else will be made available for download when the webinar is over. So you want to get an idea of how much pressure your server is under, and if you have the data, get an idea statistically whether what the trending is, up or down. You want to have a look at the profiler over time, store the information, and then look at the durations to see what you're looking at, and based on that, make the decision. As I said, the names are critical. You expect the durations to be longest for the background runtime service, and you expect them to be the quickest for those coming from the runtime, those that the users are actually waiting for. We looked at the execution plan review very briefly. There's a whole art to looking at it, but how to look at an execution plan, how to get an idea of where the heavy bits are. And we looked at indexing. I didn't run, as I said, I didn't run the query before, but by running a reindex query periodically in consult with your DBA, and repairing those indexes that require them, you can improve performance dramatically. You want to make sure that the file groups and the data and logs and the indexes are separate as much as possible to different physical drives, and you want to do this all as a planned activity rather than in emergency, because it's always easier to do it when we're planning ahead. Moving forward, we'll cover a few other items that are relevant. The IIS server, the IIS, and particularly the runtime, are where the users feel the system most, and will inevitably remark if there's a degradation in performance. If it takes another minute or two for the emails to go out, it's normally not a problem. If it takes another 3 seconds for a form to submit, my experience shows that people will respond and people will expect it to be better. The first thing you want to do is consider using external JavaScript files. If your solution is heavily human-oriented with tasks and forms, and those tasks and forms are designed are heavy JavaScript users. When I say heavy, more than 20 or 30 lines, then you might want to consider storing those as external files. If you manage them correctly, it also makes for easier maintenance, because you can share them between different workflows, and it makes for improved loading time for return users, because these files are cached. And if you keep a stable environment, this caching can save you a noticeable amount of time during the form loading. Another thing that we're going to cover now, and we're going to go to the server to do it, are Windows monitoring and logging the results, and basic networking, just to get an idea of how things work. If we go back to the server, you have the performance monitor. on every server. There are different flavors of it between the different versions of Windows Server. But the idea is, like before with the trace file, this is a graphic visualization of how hard the server is working. The parameters that you choose are important because there's a wealth of them that's almost too much information. What I chose over here, and this is available as a template file, is an idea of what's going on in the memory, the available memory, how hard the physical disk is reading, I/O limitations and lists, the processor, how hard it's chugging, that's an indicator, and the database data and log size. Depending on which server we're monitoring, of course, there are different areas we would expect to act differently. On the database server, this is typical for a database server. On a web server, there are other parameters, IIS specific, that you might want to have a look at and get an impression of what's running. As with the profiler before, looking at it here doesn't really say anything because we could be looking at it too late. The information that we have over here it doesn't really reflect what the users that are giving us feedback might be indicating. The way to check that out is to use what's called a data collector set. In essence, it samples these instead of every second and displays them. It samples them every 5 minutes or 15 minutes or however, and stores the information to a text-based file that we can easily visualize later in Excel. So if you go into the user-defined, you can create a new data collector set. And you will go about looking at the system performance and telling it what you want. And this is where you would check the different parameters and add them in. The sampling is selected over here. You run it. You choose the duration and how often you want to sample it, and the end result is a file that's stored on either as a tab separated file. You can even write it to SQL if you want, and the data is made available in tabular format to give you an idea of what's going on. I prepared, of course, in advance that we can have a look at what the results are. What you get is a tab separated file. Fortunately, I don't have Excel on the server. Sorry. The editing is really just for convenience sake. You get a timestamp of date and time. To get an idea of when the data was collected. This is collected, I think, over looks like 24 hours of time. And the different indicators that we saw before, every few seconds, over here are collected every 5 minutes. Was what I set it for. So a great indicator of how hard the server is working is the processor, the CPU percentage. Just how heavily is the CPU working? I'm not going to go into design modifications or anything of the like. But on our server, you can see a few spikes. that came out when we were running updates and when we were doing other testing activities. But generally speaking, the activity is what you would expect of a server at rest. They're running at around 7 or 8% on average. What you would expect to see if your server was under pressure would be a reasonable level of CPU. And then towards the morning hours, you would of course incorporate it into the table. Towards the morning hours, you would see a consistent rise in the CPU into an area where you would expect it already to affect the server's ability to respond. And based on that, and any other information that you would collect with the performance monitor, you can get a clear idea of what's going on. But besides the server itself, there are other parameters that affect performance. Both the ability from the user to reach the Sequence web server, and the ability of the Sequence web server to communicate with a separate SQL server. Now, as odd as it sounds, we have seen it. I have seen it myself, where a solution seems to work fine and queries are run quickly on the database server itself, but all you have to do to see the difference is to run a query on the SQL and then run it from the web server, which is physically located very close to it, and the response times are totally off the charts. Occasionally a faulty or old switch or even cabling could cause this problem, and one rough and ready way to have a look at it is the traceroute option. To get an idea of how it works, we're using, of course, a remote server, because a local server in this case wouldn't give enough data. So I chose something that I looked at in advance. It's a server in New Zealand, I think. And what traceroute does, in essence, it shows you all the hops along the way for how it gets from itself to whatever IP or address you give it on the way. I'm sorry, we're doing this from the server. The server has limited access. So the first thing you get is the ultimate goal, where it's going, and each hop it shows you the latency time. In this case, so far, 1 millisecond. It's going from my computer outwards through the main networking and out to our ISP and out to the international lines. And the farther out we go, you can see the trend is that it's going up. Now, if you have a latency of anything above 2,000 milliseconds, that means that it's taking 2 seconds just for the request to get from the source, wherever you're testing from, to the goal. And that means that you need to have a look with professional IT people why that's happening. This test is relevant both from a client that's experiencing slowdowns to the web server, and from the web server to SQL. The slowdowns can come from either of them. So we can see that in our case it was 17 hops, nothing more than a fifth of a second. So the latency in this case is not relevant. Another solution, another two solutions, which we won't be demonstrating over here, but which could give you an idea of how quickly you're downloading information from the server, especially if we're talking about client to the Sequence server, is just to place a big file, 8 or 10 megabyte text file or zip file on the Sequence server, and ask several clients to download it. And you can see the rate, the download rate. If you see something that's inconsistent or exceptionally low, that's an indicator. And lastly, it won't be demonstrating because it does require a certain amount of professional information as an IT sniffer. You can place Data Shark and variations of that sort of application to look at your switches and to verify that that none of the switching is actually to be faulted in slowdowns. This especially applies to the connectivity between your IIS and SQL servers. So we've covered the SQL, we've covered the IIS options. The next thing we would consider over here is how you actually configure the Windows services. Oddly as it is, it could be a great deal of effect on the user experience. The Active Directory synchronization service by default runs a lot. Doesn't have to run very often. Normally, if it will run every 8 or 12 hours, it's quite enough. But if you run it, if you errantly set it to run too often, it'll constantly be reading and writing out of your TVL employees, and it is a wasteful way to work. So you want to check the interval in the config file, and the other thing you want to check is the time of day, because it can be limited to run off business hours. If your organization, of course, is international and it's working 24 hours a day, it's relevant. But you'd want to choose the slope, the low time, the slow time in the day for you to run the Active Directory service. Let's take a break a second to answer questions. Just a second. Just to go over the questions quickly. Again, as with the general requirements, RAM and CPU requirements are truly solution specific. A typical SQL server can be anything from 2 or 4 gigabytes up to 32 gigabytes. It's entirely dependent on the solution, as I said, on the parameters that we had before. The counters that are recommended, as I said before, are memory, how heavy the CPU is working, the indicators for I/O, for reading and writing from the physical hard disks, and the SQL database counters. All the templates that I used over here will be available for download, so you can have a look at them a little bit later. So as we covered, the interval and the time of day that the Active Directory service runs can also have an effect on the performance. And moving on, there's the background runtime service. The background runtime service, in essence, cleans up after workflows, and it's vital for sending out tasks, and it's vital that the background runtime service run both not too often and not too spaced apart. Entirely dependent on the solution. The background runtime service can be load balanced, and we actually recommend it because if you're running a great deal of data, then you really want to divide it up so that the work gets done quicker. There is no different, as opposed to 4, there is no need to configure it manually. But when you, rather than whenever you install a background runtime service and point it to the sequence solution, it registers itself and makes the engine aware of its existence, and and the work is automatically divided between the amount of background runtime services. If any one of them fails, then no more than 15 minutes later, the sequence engine is aware that it hasn't been pulled by the background runtime service, and it redivides the workload, excluding the failed one that stopped working. Another thing to consider, as before, is the thread interval. Like I said, you want it to send the messages in a timely fashion, but you don't always need it to run constantly. When you set a thread interval, in essence, that's the break that it takes between finishing work each time. So if you have 10,000 workflow instances that are being progressed, divided up by a few background runtime services, you do want to give the database server a break occasionally, a few minutes between each time that the background runtime service runs, so that the SQL can do its thing with indexing and everything else. Another important thing is how you design your workflows themselves. The connection types between activities in your workflow are of vital importance when you look at the user experience. Seems to be a problem with the connection. Just a second. The idea being, when you have a human activity followed by several server-side activities, you don't necessarily, or you don't usually want the person to have to wait until all those activities complete for them to get the notification that they can move that the activity has been submitted. Apologize, there seems to be a bit of a slowdown on the virtual server. I'll demonstrate how you would check that out and how the sequence engine runs, because I think that my experience shows that it's not it doesn't get the attention that it should when administrators and developers set up workflows. While we wait for the administration side to load, server seems to have been affected. While we wait for it to load, does anybody have questions? I apologize for the delay. Just one moment. I will. Nope. Seems to have sorted itself. While we wait for it to load, just a general background. Your typical workflow, again, there is no typical workflow, usually starts out with an initiating activity, and and at least part of it is server side. In this demo, what I created is again, an arbitrary representation of a workflow with a form activity starting out at the beginning, and it's followed by several different server-side activities that come after it. So you have the initializing form, and after which a WCF consumer, something that happens in the database to update a legacy, queue tasking, and a switch activity, and the next task. By default, when you set up connections between the different activities, the connections are set to all, which means that if it's the runtime, if it happens in runtime, the user clicks on submit, then the engine will chase through the WCF and then chase through the stored procedure activity, and then this one, and then calculate the switch, and then go to the and send the task to the next approver. But if each of these takes only a second and a half, and you calculate the latency time for the data to go to the server and back, then the user experience is already significantly degraded. They have to wait for too long. You could consider designing it differently. If you change just this connection that immediately follows the first human activity, and instead of choosing the redirect mode all, choose automatic, what will happen is the user will submit the form and immediately get an answer back from the engine. Thank you, your data was submitted. None of the following activities will run at first. The Windows service will come on along, typically 10 or 15 minutes later, and it will patiently push through the activities, the WCF and the SPs and everything else, and take the activity and generate the task. A simple modification like that, from my experience, I've seen, can dramatically improve response times, because sometimes it's not just the 4 activities, sometimes it could be a dozen activities, and as fast as each one is on its own, the cumulative effect is not as good, especially after the data accumulates. So we've covered, if we go back to recap everything that we've covered the topology. You want to get an idea of which element in your solution you think is the core. The typical scenario that we looked at now was from the two greater culprits, the runtime and the background runtime service. And of course, they're both dependent on the SQL. We covered the usage statistics, indexes, how to look at the profiler, how to get an idea of what the expected solution is. We covered the different details, different suggestions on how to optimize your SQL database, the suggestions for the web-based solutions. If we conclude that our problem is not in the SQL side, then we have to have a look at the web. We have to look at the server itself to see how hard it's working, and to look at the connectivity between user and IIS, and between IIS and the web, and the different suggestions that we had for the Windows services, the minor tweaks that can have major effects. Are there any further questions, please? Yes, all the content, all the recording of this webinar and the different files and queries will be made available for download by tomorrow. And if you have any other questions, I'll be happy to answer them offline as well. One last question before we finish. The usage of temp tables generally in system stored procedures and in your own is a balance between what you expect the size of the database to be and fragmentation. Using table variables is the better solution for small amounts of data, a few hundred, maximum of a few hundred lists, a few hundred records, sorry. And it does less to the database fragmentation and bloating, and using a temporary tables that is better for larger amounts of data, but it does fragment the database and load it, requiring ongoing maintenance. There's a balance to that, and again, I'll be happy to assist with and send in specific suggestions based on specific scenarios and requirements. I don't see any more questions. Thank you very much, all. It was a pleasure to have this webinar. Bye-bye.